Welcome everybody. Today, so excited to have Melodi Simay Acar, her presentation on bio-inspired dynamical structural systems. Melodi teaches sustainable architecture and design to students from age 7 to 93 and all over the world. She graduated from Istanbul Technical University in 2007. Her work is bio-inspired dynamic design, and she's developed what she'll show today, novel kinetic and adaptable structures. So we are very excited to have you present to us today. Melodi.
Thank you so much for the brief introduction, and thank you for inviting me here. It's an honor to be with Field Structure Institute, and I hope you will enjoy the presentation, and I will be really appreciated with the connections afterwards. So, and I'm really thankful that Brian SD is here. Hopefully Scott Olson will join, and Julian Vincent is here. So thank you for, and all of you. And so I'm starting by sharing. I'm so excited, by the way. So welcome to the presentation of bio-inspired dynamic structural systems. So, and this is a model that I developed, and I will mention it in the meanwhile of the presentation. So I want to start with my bio and what I'm dealing with in life till my childhood. And I'm really anxious about the proportions of body and the understanding of body anatomy and cell and nature. And part and whole relationship is really making me so curious about to search for, which is connecting with the synergetics. And I'm really excited about the micro-macro connections and nature's language, structure and function, correlation, existence, and life spaces. And so I'm an architect, and I graduated from Istanbul Technical University, so which put me mostly about the art and mostly about the technical connections. And when I was in Istanbul Technical University, I had a chance to be an exchange student in University of Miami for 1 year. So it really changed my point of view of seeing the world in different dimensions, different cultures. And in that period, I really dreamt about when I am graduated, I want to go to Tokyo. I want to go to Japan. And so I started my working life in Oriental Consultants, which was a consulting firm for sustainable development. And in that space, in that place, like I have really wonderful opportunity to visit Fuji Mountain. And I learned so much from there. And also the American National Museum of Emerging Science and Innovation really connected me with the sound of Earth. So that's really that really connects me with the understanding of the vibrational analysis and everything in nature. And before that, I was really connecting with bio-inspiration, but in that sense, like I really connected with the biomimicry. And like from my childhood, I've been collecting natural structures and really observing them and playing with some dynamic systems. So after returning from Japan, I went to Izmir Institute of Technology to do my kinetic structurals research, because in Japan I come to a point like everything in nature is kinetic. So the architecture needs to adapt to the changing conditions. So that's why I choose to work in Istanbul Technical University. And in, Izmir Institute of Technology. And in there, like these books really changed my life. So especially from Fra Iotto and bone, and structure in nature as a strategy for design, and the modern building systems and biotensegrity from Graham Carr, and order in space from Kate Critchlow, and kinetic architecture from William Zook, and the biomimicry and deployable structures from Pellegrino, especially Julian Vincent's writings and essays, the articles, and synergetics, and most importantly, operating manual for spaceshippers. And of course, Krishnamurti's DVD selection of Transformation of Man, which was with David Bohm. And they take me into a place of understanding the spherical configurations, the close packing, easy to constructing, and the lightweight systems, and with less materials as nature is doing. And it connected me to biomimicry. And in 2012, after finishing my thesis, I had a chance to go to Innovation and Finance Summit. And I was in the biomimicry gathering. So it was really like a heaven for me, because it was really like the connections of the people, and which are really thinking of inspiring from nature and applying into our world. And after that, so in 2016, I had a chance to apply an article to Institute Association Shell and Special Structures. So it changed my life, that I totally focused on my kinetic structures. And in that period, like I had applied to patents, and in 3 years, I had the patent for 20 years saving of the patents. So I had a chance to make it. So I totally focused on the kinetic systems. And in 2018, I applied to TUBITAK, the Scientific and Technological Research Council of Turkey, and I founded my company, which is Kinetikhane, which is the house of kinetics. And so I try to develop the biotol building structures that I will explain. And this is the innovation that I did, and you can make different structures with that one. So today, in Tokyo, when I was presenting in Association's Shell and Special Structures, the most important title was, it's not just a matter of science, it is also a matter of art and math, the existence. So I was really searching for the background of the existence. And in the meanwhile, I was trying to learn and build natural buildings like rocket stove, composting, cob, straw, earthquake bags, and that really take me to the water cycle analysis, water waste management, organic food, and natural material using, with the orientation and lightweight and form function correlation. So this was, again, my dream of making a structure, and which can turn into a different scale systems, and which are called the biotol structural systems, that I developed in with TUBITAK's funding. So this is my studio that I tried to develop the node and all these structures with this identical node. And in 2019 and 20, like I had a chance, because of the COVID, to connect with the Global Eco-Village Network. And I became a sustainable designer and permaculture designer. And this year, with the Buckminster Fuller Institute's Design Science Studio, which was my dream like for 20 years. So I joined to Design Science Studio, and I developed some connections with especially natural body understanding with the 6th cycle of elements with Brian Esty, and which was done before for me, like the Merkaba structure with the same node that I had developed. And so it is really connecting from micro to macro for me. And I'm a teacher or facilitator in Istanbul University and Özyeğin University. And I'm teaching by inspired approach for design process. So which is really the crucial understanding right now, especially for our world. And also doing some other design courses from 7 to 93, as Bonita Marco has mentioned. And I'm trying to make some workshops, especially the point is one with nature, one for earth. And this is a new book that I just wrote, The Nature Child. So I hope it will be translated into many languages. And these are some products that I'm developing in my studio. So these are some basic of them, and different styles of like calculators and different types of modular systems. So, and it is totally connecting the understanding of and weaving, folding, structuring, and forming of nature. And this year, I had a really wonderful chance that we connected with Scott Olsen, and we did workshops based on sacred geometry, nature's language in Peru to the artists and also the artist students with the drawing and building techniques. So today, so I have a really long time that I was trying to explain myself. So today we will talk about, I will explain firstly about the bio-inspired design process and kinetic structural systems and sacred geometric connection and the novel structural systems. So I'm pretty sure all of you are so connected with bio-inspired design and sacred geometry, and I will try to make really small introduction. And so this is the one that when I was in Japan in 2008, I put design into the middle. And at that time, I wasn't any knowing about sacred geometry. So I developed this chart, like the design in the middle, in the center, and which is connecting with community, site, person, ecology, life style, and nature. And all the things that needs to be in together. So this was really a big chart for me to develop. And when I had started my master degree, this word really connects me to my design understanding. The biggest design challenge is finding the way how creators did till today, without destroying the place that will take care of their offspring and also regenerate that place. So from Jen Banyas, this really put me to understand and to put my design challenge into a way like how we can manage it. So doing it nature's way to understand from the biomimicry book. So nature as model, nature as measure, and nature as mentor. So as Buckminster Fuller mentioned, I'm not trying to imitate nature. I'm trying to understand, to find the principles she is using. So with the design science and multidisciplinary approach, I tried my best about that, especially for the structural efficiencies. So the elements of design, which are like line, shape, form, color, texture, space, value, is totally linked to nature. So from nature, I learned so much to apply into my research. And the principles of design, the pattern, contrast, emphasis, balance, proportion, scale, harmony, rhythm, and movement is from micro to macro. It is possible to find in nature. And from the biomimicry design lens, like life creates conditions conducive to life. So this is really the understanding the life principles into design challenge. So I have, yes, I have videoed that one from one Zoom web. So all life is linked. And I love the way how it zooms out to human, zooms in and out. So human is somewhere here, and we are all linked together. So this is really life challenge and design challenge is really connecting all of them, contacting with all of them. And how the fractalization is occurred. So we are all linked. And as bioinspiration is a big circle, it includes biomimetics, bionics, biomimicry, bioreplication, eco-design, robotics somehow. So it has been given so many names. And I'm using the bioinspired design, which we can manage our circle with the understanding of all these parameters. And it has a huge database, and learning from nature really gives so much opportunities for the innovations, and it really contacts with the quality of life for ecologic conscious and sustainable design and multidisciplinary approach. So as being known, like nature has accomplished multicellular evolution for millions of years with millions of species, but some of them can be cataloged. So we have so many things to learn from. And in biomimicry, they defined as challenge to biology and biology to design as two way of approach for a design parameter. And also in other articles and research, they were mentioning about like the direct approach and the indirect approach. So the direct approach is design looking to nature. So defining the engineering problem, finding a proper biological model and applying it for the technological outcome. So really, firstly, starting from the engineering problem. And the second one is the indirect approach, which is totally understanding nature and learning how nature solves that problem. So apply it to technological outcome. And for the third one that I tried to develop, especially from Julian Vincent's biomimetic map, which was the compound and holistic approach. So design looking to biology, which influences design, is mainly seeking to define the human need and identify the natural model structure and function affecting the behavior of the system and translate it into human designs for development progression. Function and structure correlation as nature's fundamental principle is gaining the importance in this design process. So especially this is the map that this really inspired me for my research developments. So taking the biology and engineering as the total mimicry, partial mimicry, and abstraction of the mechanism and understanding the basic physics and the inspiration claims. So especially in the Biomimicry Institute, they explain it like form analysis, process analysis, and ecosystem analysis. So I came to a point like the first level, especially the form analysis, has a question like what the model is composed and what the model is and composed of. And the second level is the process, what the model does and how the model does. And the third level as the ecosystem, what the model is for in this ecosystem. So trying to really connect all of them. So it needs deep looking and trying to understand every step, and new questions appear and again new answers came. And there is a website called asknature.org, and you can write like how does nature, so exploring by function, which is the most basic thing in nature, and that is connecting to structure. So all of us, I think, know about the Shinkansen train. So I had a really opportunity to travel all around Japan with the Shinkansen train. And we know that it is inspired from the kingfisher. And with that one, they have the consumption, they have reduced the consumption by 15%, and increasing the train speed by 10%. Maybe this percentages are different. But this one is really like, I just want to put this one, it's 2 minutes video. So really understanding the story behind the Shinkansen.
In 1989, Japan's Shinkansen bullet train had a problem. It was fast, really fast, like pushing 170 miles per hour fast. But every time it exited a tunnel, it was loud. The noise was coming from a variety of sources, but whenever a train sped into a tunnel, it pushed waves of atmospheric pressure through the other end. The air exited tunnels with a sonic boom that could be heard 400 meters away. In dense residential areas, that was a huge problem. So an engineering team was brought in to design a quieter, faster, and more efficient train. And they had one secret weapon. Eiji Nakatsu, the general manager of the Technical Development Department, was a bird watcher. Different components of the redesigned bullet train were based on different birds. Owls inspired the pantograph. That's the rig that connects the train to the electric wires above. Nakatsu modeled the redesign after their feathers, reducing noise by using the same serrations and curvature that allow them to silently swoop down to catch prey. The Adelie penguin, whose smooth body allows it to swim and slide effortlessly, inspired the pantograph's supporting shaft, redesigned for lower wind resistance. And perhaps most notable of all was the kingfisher. The kingfisher is a bird that dives into water to catch its prey. The unique shape of its beak allows it to do that while barely making a splash. Nakatsu took that shape to the design table. The team shot bullets shaped like different train nose models down a pipe to measure pressure waves and dropped them into water to measure the splash size. The quietest nose design was the one modeled most closely after the kingfisher's beak. When the redesign debuted in 1997, it was 10% faster, used 15% less electricity, and stayed under the 70 decibel noise limit in residential areas. And it did all that with the wings of an owl, the belly of a penguin, and the nose of a kingfisher. There's a name for design like this. It's called biomimicry.
The people who design our world usually never take a biology class. Believe it or not. So they're novices in how the world works.
So how would the world be if we understand and apply the chemistry, the physics, and mathematics of nature? So this is a question that appeared every time when I'm looking to nature. So as engineering, this is an example from textile, from medicine, from architecture, from mathematics. So technological outcomes are always evolving. And in doing it nature's way, we have so many things that we can, or so many functions that we can learn from nature for various efficient solutions. So the formulation of the problem is often more essential than its solutions, as Albert Einstein said. So the left brain and the right brain, so really the balancing of them. And as the design science, the function of what I call design science is to solve problems by introducing into the environment new artifacts, the availability of which will induce their spontaneous employment by humans, and thus coincidentally cause humans to abandon their previous problem-producing behaviors and devices. So design science is the new era like that we need to develop with the understanding of nature's principles, as Bucky is always mentioning. And it is really for the global perspective. And as Einstein said, look deep into nature, you will understand everything better. So that's why looking deep is so critical. as Buckminster Fuller have mentioned about synergy, the behavior of whole systems, and not implicit in any of the behavioral characteristics of any of the parts of the system. So the part and whole relation is really important we can find in nature's principles. So the questions are so important to answer, especially for design challenge. And my main question was, is it 1 + 1 really equals to 2? So this is really understanding the synergetics better in that sense. And the second question was, how does nature build up efficient, sufficient, and sustainable structures? So we will talk about that in this presentation. And this is really the biggest quote that's really explaining for me the natural structures are successfully efficient, not only by their minimal energy configurations with less material usage, but also their minimum effects by their interactions on our environments. So this is really highlighting the way that's how we need to think about also the interactions for our environment from Julian Vincent's article. And how does human build up efficient, sufficient, and sustainable structures is the next question that is connected with the engineering part. And it is so obvious that all the time we always admire and inspire from nature and try to build our structures. And they really led as Buckminster Fuller's research. So it's really connecting from multidisciplinaries. And also experimenting is so crucial to understand. So in this group, like all of us are really experimenting by our hands. And so this is really important to really experimentally understand the systems. So as Darwin said, like it is not the strongest of the species that survive, nor the most intelligent, but rather the one most adaptable to change. So that's why, like, especially when I was trying to understand nature's principles, I came to a point like of understanding the kinetic architecture with the adaptable properties. So that's why I put adaptable structure as my design challenge and try to understand how the growing mechanisms of nature. As William Zook has explained adaptable structures in Kinetic Architecture book, he explained 5 classifications, which is incremental, reversible, deformable, mobile, and disposable. So we will talk about this in the following period. So that really connects me with the kinetic structural systems and also connecting me to the sacred geometry after a while. So this section is the second section that I will explain about this. So this is a writing from my thesis. So the requirement for sustainable architecture is gaining its significance. The architectural design should no longer consider just in terms of today's demands, but also the life cycle and the further requirements of the built environment. That is the reason the design process should consider the adaptation to the changing conditions, which can be in terms of the building usage or environmental factors, or even in the chains of sociological demands. These should be considered in utility. Structure is the main component for living or non-living objects. So the adaptable structures have potential for using our resources in an efficient way and also for responding to the era's needs. So I just did this kinetic structures research from Google, and these are the things that appear right now. And we can see so many different kinds of and scales of applications. And Santiago Calatrava really inspired me with his way of thinking all the structural systems especially for the landmarks and the way that he explained and understands and applied the mathematics of structures. And also Theo Jansen. So I'm pretty sure every one of you know it, but the way that is sustainable with just the mechanism understanding, so with the wind it is moving. So the environmental and the adaptability is really connected. Do we really need electricity? So this is the mechanism that Theo Jansen is developing, invented this mechanism, and also Chuck Hoberman. So the way that his mechanisms really inspired me, and especially I want to explain about a thing that had happened in my studio. A child came and held this toy. It is a small one, not a big one like this. So he was just playing with it, and his eyes get really bigger. And he said, "It looks like heartbeat." And it was really like the connection of him with this toy. And this one, like, I bought it from Japan, and how the aerodynamic ability and especially the dynamic equilibrium can manage to balance is really inspired me. And especially the tensegrity systems for the kinetic systems, which I would love to focus, is when I read the Architecture of Light from Ingber, especially in my thesis period. So he was mentioning all the cells are totally connecting and working with tensegrity principles. I was really like, yes, this is the one that I need to focus. So the tensional integrity is to stabilize the shapes of living cells and to determine how they respond to mechanical forces. Is really the thing that's my innovation is totally connecting with that sense. And from Vitruvius, the main book of Vitruvius is saying to connect with the multidisciplinary approach, and also Utilitas Venustas Firmitas, which really puts me into the architecture eyes into that way. So to really think about usability, durability, and beauty in the way of sustainable and adaptable and durability. So these are really the main connections that I'm searching for my design challenge. And for the mechanical aspects, so normally the mechanical structural efficiencies that we know is like with the 6 elements, it is planar moving. So that's why I got this one from the internet. And so the 6th system is mostly about planar movement. However, in over-constraint mechanisms, everything is changing to, especially connecting with the geometric aspects. So there is always another way of doing and applying. So for the adaptable structures, especially as William Zook mentioned, the incremental, reversible, deformable, mobile, and disposable classifications are really important to understand the adaptability. So it has all, the cell has all these classifications and properties. So that's why I try to focus on how a cell membrane is composed of. And as Bucky said, like the systems of like 1, 2, and 3, they are always in a dynamic, movable places, but when it gets the fourth one, it gets its stability. So that really highlights my way of thinking, the Venustas firmitas utilitas way of thinking. And so the cell membrane is really especially with the understanding for the architectural connection with the outer and inner space. So the membrane is really the importance for our buildings and building environments. So that's why I connected to cells. So why cell is so important? So we have countless living cells. And we have like 100 trillion in our bodies, and they make us. And cells come on in all shapes and sizes and different functions to perform life. And they work together to form the tissues of all living things as we are. And all of us started life as a single cell and divided again and again and again. So as platonic solids. So this is really connecting me to the platonic solids. And from micro to macro, from cell to cosmos, everything is connecting. And this is also connecting me to sacred geometry, understanding. And from cosmos to earth grids, and from Leonardo da Vinci to music notes, and also our body cycles. And in this year in Buckminster Fuller Institute, I had a presentation about livingry, and I say like nature's way of iteration and repetition from micro to macro, from unseen to the seen, from our body to our environment. We are the part of this flower of life. So that's why it's really connecting me to the sacred geometry, which is ageless wisdom. So that's why it's really like connecting with the nature's language and with the cosmic consciousness. And as this year, like I'm really appreciated by Scott Olson, like he really find out and really pointed that the deep look is the way that I really connecting these systems. So this is really precious for me. And another thing that I want to share from Thich Nhat Hanh, and I was really lucky to find this book in Peru, and it is really connecting with deep looking into our own nature and our relations. And in his book, True Love, he was saying, training is needed in order to love properly. And to be able to give happiness and joy, you must practice deep looking, directed toward the person you love. Because if you don't understand this person, you cannot love properly. Person or environment or anything we are doing. Understanding is the essence of love. If you can't understand, you can't love. That is the message of the Buddha. And what we do in order to understand a person and our environment, nature, we must have time. We must practice looking deeply into what we are really trying to understand. We must be there, attentive, we must observe, we must look deeply. And the fruit of this looking deeply is called understanding. Love is a true thing if it is made up of a substance called understanding. So right now, I would love to go to a gallery view, and I would love to ask all of you to open your cameras. Did I stop sharing? Okay, welcome everyone. And I would ask to you, I had asked to you to bring your toys. I hope you bring your toys with you. So right now, just like a really little break and little break of understanding each other. Like I would love to hear, like till now in this 50 minutes, like what you gained till now, or what you have a question. Do you have a question in your head? Just whatever comes, like a word, a sentence. And I want to start by saying and giving an example, like, so this is what I'm holding right now as a toy. So as a presenter, I thought like, so in this presentation, really, especially in this presentation, while preparing this presentation, like it really connects with my roots. So, and I'm really thankful to be here. And I want to throw my ball to Brian. Do you have a toy with you? So just like one sentence or one word, whatever you want to.
I have a word. Had.
Okay, throw the ball to Brian and everybody will throw whatever they want to to the other person. Yes, Brian.
So my favorite model is the human foot. Now, yeah, I wouldn't know what to say about it. It's too mysterious for me. So, yeah.
Mysterious is the word.
Mysterious.
Okay, so who do you want to hear from?
Oh, Gary. Let's go, Gary.
All right, Melody, I love your presentation. I'd like to introduce kinetics into my models as well. And this is just basically 4 hoops that are kind of joined together. And they model the cube octahedron with the vertices of a cube octahedron. And it'll just spin in a certain fashion, but in fact, there is a state transformation. There's 3 stable states it can transform through. And so I had fun making them.
Perfect. Do you want to share a word for the presentation?
I'm sorry, Melody, was that?
A word for the presentation, whatever word come to you. Is there any word that you want to share with us? Also, transformation maybe.
I'm sorry. I'm sure I'm going to have some difficulty in hearing because my hearing's not that good, but love your presentation. And you must have a library that is equal to what I have because I noticed almost all of the books and the illustrations and the drawings that you did are included in my library that I have sent around from time to time as a design science library. So it's I love that understanding that you're crossing so many disciplines in your work. But I noticed that you didn't have very much in terms of the jitterbug that Fuller did in the geometric transformation model. And here is, if I can get it up there right. So this is a chiral form of the jitterbug that Bucky did, which was started with one of the elements that you talked about from the closest packing of spheres. And when he removed the center sphere, he got his jitterbug concept and idea. And one thing that's so interesting about that form is that it becomes, if you start with the tetrahedron, and it starts going through that transformation.
Okay.
It goes into the octahedron, and from there you can create all of the regular and semi-regular polyhedra, plus many, 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 many more. So the transformation of that rotation and the translation that's going on has so many applications into biology and physics and chemistry and biometrics. And it's really, in my mind, one of the beginnings of the kinetics that you find going on in the growth in nature. So it may be something of interest to you if you haven't started to explore that yet.
I just want to add something. Thank you for your comments, Clinton. Like, it is, my presentation is not finished. It is just like a sharing of what we have taken from this in this 50 minutes. So just like a word sharing or a sentence sharing, and then we will continue to this presentation, and afterwards we will have discussion session and Q&A session.
I have one thing to share.
Perfect.
And that would be kinetic tensegrity.
Kinetics and integrity. Perfect. Thank you.
There you
And
go.
who you want to hear, Gerald?
Al McMahon.
Don.
I'll need just a second.
I have a quick word.
Okay, Bonnie, you go.
Okay, it's an acronym, CADS. We named Comprehensive Anticipatory Design Science. We brought that down a little bit to CADS. And you have done probably one of the best presentations or introductions to Comprehensive Anticipatory Design Science.
Who do you want to hear, Bonnie?
Don.
Yes, I was very intrigued by your presentation, particularly where it goes into how forms transform one into another. What is the mechanics of that actually, in strict mechanical terms? And the way field structure theory approaches this problem is by looking at the polyhedral nucleus of a form and its fields, which are formed by these loops, and these loops make the polyhedra that form in the center. So really form is energy in forms of loops, and this energy can change into particle, atom, molecule by restructuring the loopage. So this form, which is the particle model, transforms into this, the atomic model. And if you see, there's a nucleus in the center and a triangulated field of energy around it. So this is the atomic model, a nucleus with a field around it. And it's all done by reforming the loops. And then the atomic model transfers into the molecular model. And here we have the nuclear events of two atoms. These are tetrahedrons joined by a circuit. And in physics, that circuit is called a valence electron. It's the one that connects to all the other atoms in the molecule. So you can keep building up your whole scale of reality from molecules to cells by restructuring the loop energies that are tying this all together.
Thank you so much, Don. And who you want to hear?
May I just insert something? Pardon me for not raising my hand, but I want to thank you for emphasizing the importance of adaptability and change, because there are literally, in my opinion, billions and billions of dollars lost with regard to buildings and other things that have to be destroyed because they didn't have the most simple adaptation features built into them that would have probably cost a few dollars to do. And one example that I think we all know about is all the, including old homes, all the and buildings, all the things that were built with very thick concrete walls and no holes in them to add additional miscellaneous things through the walls. If
Thank you so much, Carl. I need to, like really, I have a really limited time. We have all of us. So that's why like I want to continue with all of us, hearing all of us. So we will talk about it in the questionnaire part. Is it okay for you?
Great.
Thank you so much. Do you have a toy to share?
I'm sorry, I didn't get that.
Okay, so maybe at the end part. So Albert, I will
So-
choose, sorry.
Just real quick, resonance and interference, because we're all familiar with the jitterbug, but if you actually spin it so that it interferes with itself, it becomes solid.
Okay, perfect.
That's all.
Thank you, Albert. Bo? Do you want to share a word? Bo Atkinson?
Oh, I'm sorry, I didn't hear. I don't have anything particular. I have too many things, so let's just leave it there. I know that you have a good program to finish up. Thank you so much. Love it.
Okay, thank you. Blue Sky Timer. You're Sam, right? David?
Hi, Melody. Thank you for the spectacular presentation. Appreciating the comprehensivity. I brought my jitterbug we made with our daughter, thinking about transformations, but also thinking about how you're bringing in many things related to the biological and the ecological into the synergistic and the transformative. And it's reminding me of Lynn Margulis's notion of the holobiont, which is the nestedness and interrelated symbiosis of species, which I think is extremely important in the context of what we're talking about in terms of transformation, and something I'd love to see more woven into this dialogue. Thank you.
Thank you, David. Scott?
Ingenious. Melody is probably the wrong language, our secret weapon we brought to Peru. I'm so proud of you. Since I've been able to communicate with you regularly, one of the things that happened is I kind of fell into a non-ordinary state of consciousness, and I started to look at this a little bit more closely, and I realized if you almost look to the tips of it, it's almost like a hand with fingernails. And just wanted to share that with you, but thank you for what you're doing. Tremendous.
Thank you. And Al Makwan, I'm not sure if you spoke.
Yeah, I actually am just logged on two different machines by mistake. So.
Okay, do you want to add something? Because you need time, as I remember.
What's that?
Okay, do you want to add something?
No, resonance and interference, things that line and things that interfere form structure.
Okay,
Talk to you later.
You so much. Thank you. Julian Vincent, if possible.
Well, yeah, thanks. I mean, you only asked me this morning, so I wasn't prepared for anything. I'm very like origami, but I live in a very small house and there's no room for any of these things. So it's all in my head.
Okay, thank you so much. And Gerald?
Scott, that reminds me of the jitterbugging in a different form, which if I can get this one to work, it's been around for years. Anyway, basically it will transform from the icosahedron to the dodecahedron. And it's basically a linkage of an intersection across the center of the two polyhedra. So you have the duality, and the piece that you just showed almost looks like it could go or may have developed in that manner. So thank you, Scott, for reminding me of that.
Okay, so I am continuing. I didn't forget anybody, right? Okay, perfect. So I'm continuing my presentation, and thank you for all your comments. So I add also the words to our chat. And that's, so for the last slide, especially before the, okay. So thank you for all your puttings into our hub. And so this is the way that I really want to have interaction in the presentation, so we can all hear our voices, and this is really important. So this is my atelier, Harekethane, and Kinetikhane is my company. So if you have any comments, this is my email, so please connect with me from this email. So thank you for this participation. And now we will stop recording, and I will start for the novel structural systems.
Thank you. Thank you so much, Melodi. We'll open up for Q&A. We're about 5 minutes till the end of our session. If those of you would like to stay just a little bit longer, Melodi, 5 or 10 minutes longer after 9, if that's okay, please use your reactions below to hold up your hand, and then Melodi will call on you. I see we have already Don and Gary are ready to ask questions. Melodi, go ahead.
Thank you, Don. Oh, no, you are muted. You are muted.
You're muted, Don.
Okay, I think I'm back in the world. Remind me, please, what TOL stands for?
Triangle of life.
Triangle what?
Of life.
OFF?
I will write from the chat. Is it okay?
Triangle of life. Okay.
Yes.
Okay, got it. Thank you.
Is it just a question, though?
That's all.
Okay, Gary.
Yeah, Melody, I love your work. I've gone down so many similar paths of finding a very simple shape that can build up to make larger components, and those components can make larger components. So I'm looking forward to a much longer chat. Are you coming back next week for a question and answer? Is that?
We need to talk about that, and I would love to join your gatherings, but it is always on my Saturday night, so it is really like my time is really I couldn't manage it till now. Hopefully I can manage after this.
So your triangle of life, I guess that introduces 2 angles of freedom. You can rotate in 3 different axes at the same time.
Yes, it is 3-dimensional behavior.
And the torus design that you show with that wire, is that one continuous piece of
One
wire?
continuous, and when it is divided, it is two.
'Cause I'm seeing some very similar structures when I'm playing with a tetrahelix design. It's a simulator that, and so it is a single circuit that makes very similar shapes, but I can define on the basis of a tetrahelix with a variable twist on it. And it's just amazing that it comes out with some similar shapes.
You said like tetrahelix. Did
Yeah,
you do that or?
Yeah, I could share a screenshot of that. I don't know if you can see that.
Yes, we can see it.
Yes.
Oops. Oh,
So the wire has a formation also.
yeah, these are actually each segment is an arc that you would find inside a tetrahedron, and I just found it very curious to come up with some very similar structures.
Yeah, this is totally the way of how nature is weaving itself, I guess.
Thank you.
Thank you so much, Gary. Albert?
Hi, oh, what a wonderful presentation. A couple of things. Number one, I'm only imagine you have a very busy schedule, but if you were to find times that would work for you, since this is kind of a global reach, it's different times and different days. I'm sure, I know you've got connections with Bonnie and such. If you'd let us know what windows you have, and we could kind of look at the clocks, we might even be able to have other gatherings around that availability. So wouldn't want to stop that. The second is, where can I get some of your triangle of life? I imagine that it's a little premature for there to be a 3D printed module to come out until you're it's more established because of the patentable rights and patterns and such and such. I'm a huge fan. My day job is to teach people that go in and make houses more energy efficient, and thanks. And I love that. That's I'm inspired by Fuller and structure and structural components. And right now, building yurts or small deployable buildings, one of the things that's actually missing is the platforms to put them on unstable ground. That's a huge focus that's missing everywhere. So anytime you want to have any discussions, or as I said, even set up some times that work, it's nice to live in the future. I'm a big believer in what I call a system of systems and structure of structures, and that everything from our body, a car, a motorcycle, house, the cell, and I often use the cell to a house comparison when I make sure that the students that I'm talking to aren't going to think I'm too crazy. But I imagine there's an awful lot. I hope we do get an opportunity to do some feedback. And I just wanted to congratulate you and say that was a wonderful presentation, and thank you so much for sharing.
Thank you so much for all your comments. And I would love to especially arrange a time, and or I will try my best, but as I said, like it's a Saturday night. And I would love to arrange a time and develop it for the future works totally, especially with the housing, because I that's why I'm focusing on that. Thank you, Albert. Any other question or adding? If not, I will add something. So especially for the making this system with, as I said, like the formulation is not known right now. So these are the things that I really want to focus on PhD with the synergetic understanding people. So I would love to connect with this way of thinking, and for the structural building for our world, for our spaceship Earth. So please connect me about that. I will be really appreciated.
Want to thank you for your presentation. It was wonderful. All of us are deeply inspired. Yes, a round of hand there.
Yeah.
Thank you so much, Melody. So for those of you, David, Scott, Brian, Julian, are new to us, please look on the chat. I have put up the link to join our FSI community network. You could also check us out at the Field Structure Institute website, and also our YouTube channel has a number of talks from our recent, from this past year, a little longer. Thank you all for coming. We will have a roundtable next week, unfortunately not with Melody, but perhaps in a Saturday coming up, or in that extra day, we'll be able to have a roundtable around your novel structures. So we can do a little more model playing with models. Serious play. The last thing I want to say, Melody, is micro-incisive, macro-inclusive. Bucky's ideas for how to design. You've embodied that. Thank you.
Micro, can you repeat it again?
Micro-incisive and macro-inclusive. It is the scale-free way to design. We call it scale-free or multi-scale design now. So thank you all. We'll see you next week.
Bye now.
Thank you, everyone.
Very nice, Melody. Thank you. Awesome. Very good.
Thank you, Sam.
Sorry for the interruption. I miscued.
It's okay. Don't worry about that.
Okay, thank you.
Thank you so much.